Hello everyone, I am Miss Ysaguirre and today I am going to be talking about matter and energy. Let us make a start. You might be asking yourself, what is matter? For that, we must take a look around us. Have you ever looked at the sky and wondered why it is color blue? How about the water that even though we can see it, we can touch it, can never say in our hand, as it always passes through our fingers. How about a block of ice, which is water? However, it is in its solid form. Whenever we put it in our hands, it begins converting back to water. Hmm. These are things that we can find all around us. In other words, they are matter. Matter can be found in our entire universe. They are made of atoms and molecules. Atoms are very small particles of matter. They are the major building blocks of life. We can see them, we can touch them, sometimes you can hear them. Matter can be defined as anything that has a mass, meaning their weight, and anything that takes up space, which is their volume. There are three major types of matter. We have them being solids, liquids, and gases. Let us continue. Now, what are the different particles in matter? As I mentioned previously, there are three major categories being solids, liquids, and gases. They are made up of atoms and molecules. These two work together. Atoms are defined to be the basic building blocks of matter. A molecule is the smallest thing that you can find and it can be divided. It's the smallest substance. So it doesn't matter in how many parts you may cut it. For example, if we would have a piece of wood that is measuring 1 feet and you cut it by inches, it doesn't matter. It is still going to be in its solid form. It is made up out of two or more atoms that are bound together through what we know as chemical bonding. For us to take a look at what I am talking about, I have here on the screen an example of water, the most essential liquid for us to be able to survive in today's world. If we take a look at the illustration, here we can see that a water molecule is made up of two elements, being hydrogen and oxygen. It is comprised of two atoms of hydrogen and one of oxygen. Hence the reason we come up with H2O, or what is known as water. Let us continue. Here, I have a chart visualizing these particles in matter. Now, the first one is showing the solid. As I mentioned previously, they have particles which are atoms and molecules. These are tightly compact together, meaning that they are heavily attracted. It makes it rigid, giving it that solid form or shape. So it has a fixed shape and it has a fixed volume, and these cannot be squashed. It doesn't matter into how many pieces you cut them, they still keep on having that fixed shape. Why? Because they are attracted, meaning that they're tightly packed together, as we can see here in this image, and they have no space for them to try to pass through each other. If we take a look at the components of liquids, we can see from the picture here that the particles are a little bit loose. They are not that rigid as the first. So that means that these molecules can pass through each other. They have no fixed shape. So that means that if I would have right now a glass of water and I want to pour it into a larger container, it is going to take the shape of that container, even though it has the same amount of water being its fixed volume. These as well cannot be squashed. Now, let us take a look at the third one, which is the gas. If you take a look at the gas, the particles are not rigid. They bounce back within each other. They have no shape either way. No, they as well have no fixed volume. The reason is that they normally take the shape of wherever they are, this due to their spacing out. The same thing with their volume. For example, if I am to spray right now a perfume in a room, even though it's in a liquid form in its bottle, whenever I spray it, the entire room will be filled with the aroma of that perfume, as it doesn't have any shape nor volume. It will take the space of the entire room. Hence, the reason why, whenever somebody sprays perfume, we can smell it from afar. The same thing happens with things like Fabuloso because they have gases within them. Let us take a look at some perfect examples here in other worldly things that we can find them. The picture on our left, as you can see, the gentleman the picture on the left is illustrating as follows. The gentleman has a hammer, he has a nail, and he has a piece of wood. These are all what we call solids. Even though he is hammering the nail into the wood, we do not see a change in their shape. Yes, there are vibrations, but because, as we can see here in the picture, because they are tightly compact together, they are attracted, and as a result, only vibration occurs and they are not broken. So that means that it keeps its same shape. This picture here on the right, and I use an image that has another object within it, which we call buoyancy, to show that the water has movement. If we take a look here in this picture below, we might be able to see the particles that are slightly apart. Whenever we would squeeze the bottle, the particles would be moving. This is as a result as well of the gas that is within it. Because remember that water has oxygen within it. It makes it difficult for us to be able to squeeze that bottle due to the gas. Let us take a look now at the final example for the state of matter. Here, we are seeing the picture of a little girl that is amazed to see what is going on. If we take a look at the illustration at the top, we can see that the bottle, even though it is open, we might say that there is nothing in there. Probably we would ask, do you think that this bottle has something in it? Children would say no. However, there are gas particles inside this container. If we would place a balloon like how it is shown in this illustration, in both illustrations, whenever we would squeeze that bottle, the air or the gas that is found within the bottle will cross over to the balloon. Hence the reason you can see the little girl face being amused. Why? Because she is squeezing the bottle and the balloon is going to be blown up. If we keep on with this pressure, it fills the balloon and we can make it bigger. Whenever we would lose the battle, that we stop squeezing the battle, we would see a change that the balloon would go back, because then all the air that has been into the balloon will go back into the battle. Let us continue. Okay, so now here we have what are the different changes of state. So now, what are the changes of the states of matter? Well, as change says itself, it is a physical change of whatever substance we are talking about. They are reversible changes and do not involve any change in chemical makeup of matter. Common change of the states are melting, freezing, sublimation, deposition, which we also can call resublimation, condensation, and evaporation, or we can call it evaporation. Let us take a look at the chart that follows. Now, let us take a look at the change of state. Here, we can have different changes occurring. These can be from solid to liquids, solid and gases, and between liquids and gases. Let us begin with the first one here, from liquids to solids and vice versa. Now, we have from going to a liquid to its solid form, what is known as freezing. What happens is that heat transfer occurs between the warmer tray and the colder air in the freezer or in any temperature that is colder. The warm water loses the heat through the cold air in the freezer. This heat transfer occurs until there is no energy that is available for the particles to slide past each other, because remember that I said that the liquid particles can pass through each other when moving from from a liquid form to its solid form. We have here now the particles that become more attracted, and there is a force within them that keeps them rigid. Hence, this process is called freezing. Normally, the temperature at which it occurs is known as the freezing point. Now, if we would want to change it from a solid now to a liquid, especially like this picture here is showing, we would take out the ice cubes from the freezer and place them in a warm room, what we call to room temperature. The ice after a while would be absorbing the energy from the warmer air around it, and from there on, the force of attraction that has been holding it together, being solid as a cube of ice, will soon begin releasing itself, and it will slip out from that fixed position, um, converting themselves into its melting point, going back into liquid. No, the melting point is the temperature at which a solid changes to its liquid form. If we continue, as I mentioned, we can change between what are solids to gases and from gases to solids. Here, we have what is known as sublimation, changing a solid to a gas. Now, the process of sublimation is one in which the solid directly changes to a gas. This occurs when solids absorb enough energy to completely overcome the forces of attraction between them. Here we have a perfect example of what is known as dry ice. This is a solid that normally goes through sublimation. Just as what happened with a solid converting to a gas without going through the liquid process, we can have the inverse from a gas to a solid, which is known as disposition, or as well known as resublimation. Now, this phase transition is one in which the gas transforms into solid without passing through the liquid form. The deposition is a thermodynamic process, And as I mentioned previously, it is the reverse of sublimation. For example, here we can see a beautiful gem that from being from its gas state have solidified, and now it looks like somewhat like glitter. This process occurs in inverse position. As I mentioned previously, they jump its liquid state and can either pass directly from being a solid to a gas or a gas to a liquid. Now, if we take a look, there can also be changes, as I mentioned previously, between liquids and gases and from gases to liquids. We have what is known as evaporation or evaporation from converting from a liquid to a gas and from a gas to a liquid, which is known as condensation. Now, you might ask what is evaporation or another term which is known as evaporation. Well, here we have a perfect example of a cup of tea that is steaming hot. Whenever we take a look at water, it begins to boil, it makes up bubbles. These vapors are water vapor are formed in the boiling water. This happens as the particle of liquid water gain enough energy to completely overcome the force of attraction between them, changing them into its gaseous state. That's the reason why we can see somewhat, some people call it like a little smoke or the steam. This is known as vaporization. When the bubbles rise through the water, they escape from the teapot or from a cup, as we are seeing in this image, and it changes to this gas form. Whenever this happens, they say, or it is referred that the temperature at which a liquid boil is called its boiling point. Now, there is an inverse process that can occur, as mentioned, going from gas to liquid, which is known as condensation. This is whenever you would take, imagine that you're taking a hot shower in a closed bathroom. The mirror is likely to fog up. It's the same thing whenever there is a lot of heat and we are driving and there's a lot of fog. This is what happens. This is sort of condensation. Now, some of the liquid comes in contact with cooler surfaces. The cooler the water particles are, they no longer have energy to overcome the forces of attraction between them. They come together and form droplets of liquid water. That's why whenever we take out the water and we see them, that it is, some people call it that it is sort of sweating, that some bubbles or some water droplets would form around that glass. That is what we call condensation. So they come together and form these droplets of liquid water. The process in which gas changes from a liquid is known as condensation. So here we have the different sections of the changes of state of matter. As we can see, they can change from solid to liquids, liquids to solids, from liquids to gases, gases to liquids, and from solid to gases and gases to solids. In other form, they are like a little cycle that they can be changed between. And as we can see within them, for example, with deposition and sublimation, they can actually move away and not needing to change to the state of liquid form into when changing into a solid form, and vice versa. Let us continue with energy. Let us take a look at the different forms of energy. Energy is essential for life. It is the ability to do work and allows us to live. There are two major types of energy, which are kinetic energy and potential energy. Now, energy is the ability to do work or to make objects move. For example, the energy that is stored in fuels like gasoline can be used to make a car move. The energy in the gasoline is a form of energy called chemical energy. Now, let us take a look at the two major types of forms of energy, which are kinetic energy, an energy that is in movement, and potential energy, which is stored energy. Under kinetic energy, we can find the following: thermal energy, mechanical energy, electrical energy, and magnetic energy. Thermal energy is one that you can see that has moving uh, particles, for example, heat. Mechanical energy would be one that has an object in motion. Electric energy is a type of energy that has its energy running through wires. For example, we use electric energy in our house, for example, for heaters, for also use the blender to turn on the light. Magnetic energy now is a type of energy that is used in either push or pull motion. We also have what is known as sound energy. Sound energy comes in the form of things that we can hear. For example, we can hear when a printer is printing, we can hear a refrigerator working, the music that comes from a boombox or a speaker. Also, we have light energy. Light energy is a type of energy that we use under potential energy. We have chemical energy, we have elastic energy, nuclear energy, and gravitational energy. Chemical energy would be the type that is stored in fuel or food. For example, when we consume products, that energy is stored in our body. Whenever we would want to walk, we are using that energy. Elastic energy is one that is stored in objects such as rubbers, okay, as they can be stretched. Nuclear energy are those that are found stored at the center of particles. These are normally found in objects such as bombs. Gravitational energy is a type of energy that is normally stored in objects when it is above the Earth's surface. Let us continue. Here I have examples of what are the different types of forms of energy. I am going to begin with mechanical type of energy. Two basic examples would be that of a leaping frog. Two examples would be that of a leaping frog or a moving car. In thermal energy, as I stated previously, it is one that involves heat. For example, if we would be eating an ice cream and we place it under the hot sun, it would begin melting. The same would happen with a soup that we are cooking, it would be heating. With electromagnetic that deals with light and sound, we can see a visible light bulb from very far away. Also, there is infrared radiation and radio waves. Hence, the reason why we're able to listen to music coming from a radio station or to our favorite morning show every day. Now, examples of electrical energy are such as the power lines. As I mentioned, this type of energy needs wires. Without electric energy, we would not be able to have our cool water in our refrigerators, nor be able to heat food in the microwave, nor to watch television. A natural form of electrical energy is lightning. Next, we have chemical energy. As I mentioned previously, we normally buy food at the supermarket, or we can grow them at home and we eat them. This is stored in our body, and whenever we are ready to work in any form, could be in speaking, even in breathing, walking, or simply writing, this energy is used. As well, we have chemical energy that is stored whenever we have a match. Whenever we strike a match, it turns into fire. Next, we have nuclear energy. This is one that has nuclear fission, which is a combination of the sun and the stars. These are normally gases. We have as well nuclear fission, which is inside, or we can say that at the center of the earth, which is the earth's core. Let us continue. Have you ever wondered how we can go about without energy if we ever run out of fossil fuels such as coal? Interesting, right? Now, there are alternative methods that we have on Earth that can be used to provide us with energy. Let us take a look at them. Alternative form of energy would mean something like an alternative would be like a backup. It refers to energy sources other than those such as fossil fuels such as coal, petroleum, and diesel. Mostly, it includes renewable energy sources, for example, wind and solar energy. As you can see here are six different types: solar energy, wind energy, hydropower energy, biomass, tidal, and geothermal. Now, here I have the first two. Wind energy is one of the cleanest and most accessible sources of energy. The energy is used naturally from the wind, and it does not release any carbon emissions as a byproduct. It is also renewable, as there will always be wind on Earth. A typical wind farm repays its carbon footprint in around 6 months or even less than 1 year. This provides decades of zero emission energy that displaces fossil fuel energy. As you can see here, the wind turbine is turning around due to the wind. It produces energy. As you can see, there is an example here of a toaster toasting some bread. So they are using wind energy to transform to machines. Our other type of energy is solar energy. This is probably one of the most common known sources of alternative energy in today's world. As we are aware, fossil fuels are non renewable. Using the sun is one of the best alternatives, as it is renewable, knowing that we cannot deplete the sun. At first, you might see that your bill is very high due to our regular type of electricity. However, When you would change to a solar system, even though it might cost you approximately $15,000, after some years, you will be able to recuperate that money as you will be saving a whole lot using that sun to convert using the solar panels into energy to give power to the house using different appliances. Let's take a look at the other two. Nuclear energy is a type of energy that is taken from the core of atoms. This must include a split to gain this type of energy through a process that we call fission. It is harnessed in a power plant as I have here in the picture. This is what we would have a nuclear power plant, and normally it is near a water body due to the heat coming out of the power plant due to the use of these atoms. Now, energy is produced by using some rods of nuclear material to adjust the amount of electricity that is produced. The more rods that are present during the chain reaction, the slower and more controlled the reaction will be. Removing rods will allow a stronger chain reaction to create more electricity. This these nuclear power plants normally give electricity to nearby places. Now, people are normally debating if whether nuclear energy should be considered renewable, as people think that there will be one day that they might end up not using any more atoms. Next, we have hydrogen gas energy. This is an important energy carrier and a potential alternative for clean energy. However, hydrogen gas is largely produced from fossil fuels. Many environmentalists think that this is becoming a threat to our environment. A most sustainable version of this energy source has been described as biohydrogen, and there are hopes it will be derived from organic, biodegradable waste in the future. Next, we have what is known as tidal energy. This is the method of energy production that is still fairly new and has only produced a small amount of energy so far. So it is a long time before we can see real results from the tidal energy. As you can see, they put turbines either a sea, a river, or another body of water. They expect these turbines to move with the tides as they rise with the power of the water moving with the turbines, they expect to have energy. But as I stated, this is just a new phase. Probably in approximately 15 years, we're going to see more tidal energy being used in our world. Next, we have what is known as biomass energy. This type of energy can come in several forms, as it can include anything from the burning of wood to burning of waste. With biomass in the form of burning wood, the heat generated is often equivalent to that of a central heating system, and the costs involved to tend to be lower than household or building that use fossil fuels such as coal. It's not, however, a green energy source, even if it is technically renewable. Next, we have what are known as biofuels. Biofuels are somewhat similar to biomass. However, these are biological matter, meaning that these come from either animals or plant, and these are converted, as you can see here in the picture, from being a dead material into energy. Biofuel is renewable when plants are used because of course they they can always be grown, we can always replant them. However, they do require dedicated machinery for extraction, which can indirectly contribute to increased emissions even if biofuel themselves don't. So this is a type of energy that can be used even to fuel a vehicle. Now, let us take a look at energy and machines. A machine uses energy to make our work easier by changing either the size or the direction of the force. For example, if we would have to break a nut with our bare hands, we can probably get hurt and it would take more time to crack the nut. For our life to be made much more easier, we have these machines. So instead, we would use a nut cracker like how I have here in this picture to break the nut, to crack the nut. Now, how are machines energy converters? Well, certain machines are designed specially to convert one form of energy into another. For example, we can see a car's engine. Chemical energy turns into thermal and kinetic energy to make a car move. For example, with the windmill, we use wind, which is a natural source of energy. It is as well a kinetic energy. This turns into electric energy. Therefore, with that type of energy, we are able to even toast slices of bread. You may be asking now, what are the different types of machines? Well, we have simple machines that do not require the electric type of energy. We have inclined plane, we have the lever, we have the wedge, a screw, pulley, wheel, and axle. And these are all types of kinetic energy. Now, if we take a look at an inclined plane and all these other types of machine, they make our life easier. For example, the inclined plane would be a ramp, stairs, and even a roller coaster. It is any slope, like the image here illustrated, or ramp that makes it easier to lift something. For example, if we want to take a box up, all that we can do, place the box, use a rope, and pull it up to where we want to take that box. As if we would want to take the box by carrying it in our hands, we would need to put more effort. An inclined plane, such as a ramp, would assist us in making less effort. Next, we have the lever, which is a rod balanced on a fixed point that can help lift a heavy weight with less effort, such as a rake, fork, the scissors that we use to cut paper, and a hammer to hammer nails. Next, we have the wheel and axle. This is used to carry loads around easily for long distances with less effort. For example, a wagon, a bicycle. If we would like to go to the store and we don't want to go walking, we can always use our bike. We would be using energy to pedal the bicycle. That would be less effort and less tiring than walking a long distance. It would even make our life easier as we would spend less time going to and from the store. Also, for those of us who love to bake, especially cookies, we need to stretch the dough. Instead of doing it with our bare hands, we can use a rolling pin. Next, we have what is known as the pulley. Pulley uses a wheel and a rope, as we can see here. This is used to raise or to lower or move a load. For example, to lift a pail or a bucket of water, we can always clip it, the pin, like a pin or like a hook, and we use the wheel here and we pull the rope to have our water come out of the well. Also, the ropes that are used in a sailboat, those all use a pulley. As well, for our windows, we have the window shade. If we want to bring it down, we must need to pull the little string that it brings, and automatically we would have light out of our rooms. Here we have the screw. This is as well an inclined plane, which is wrapped in a spiral, meaning that it goes round and round. We have a screw that normally can be drilled or with the use of a screwdriver can be screwed into a wall for us to hang probably a frame. We have a jar lid, a bolt. So these are examples of things that we find in our everyday that makes our life easier. Finally, we have the wedge. The wedge is made up of two inclined planes and it is used to push objects apart. For example, here I have illustrated an axe. If we need firewood, we can always go and cut the different chunks, but we need to cut them into small pieces. So we use an axe to split them. Also, we have push pins. In our class, we have bulletin boards. Push pins are used to hold the paper and to pull apart the board. Finally, we have the nails. These are all examples of simple machine and they make our life easier. I would like to thank you for your attention. I hope that I have helped to broaden your knowledge in these topics. Goodbye.